right, so here, excuse me, our textbook does not give us these types of questions very often, but the AP exam loves to give you questions like this. They are easier than the ones we have been doing. Okay, so be glad if you get something like this. They love to give you like multiple representation sort of problems where you've got graphs, you've got tables, you've got to like see how everything is related here. So it tells us the graph above, f of x, and the table above gives selected values of the derivative of f, which is f prime of x. So this is the graph of f of x. This graph right here is f of x. And then we can see labeled here our table is f prime. We are supposed to write the equation of the line tangent to the graph of f at x equals -1. And then we're supposed to graph that tangent line on the graph above. So, equation of a tangent line, we did one of these at the end of class yesterday. There are 3 things you're going to need for the equation of a tangent line. You need the point, which in this case is going to be f of -1. You need the slope, which is going to be f prime of -1. And then you need the equation, which is where you plug those things into y equals m times x minus x1 plus y1. So this is actually going to be pretty easy for this because we don't have to do limit definition of a derivative for anything at a point or anything, because they just gave us a list of the derivative, right? The first thing I want to do, though, is find my point. So I need f of -1. What do I have to do to find f of -1? Just look at the graph. You're looking for where x is -1, which is right here. What's the y coordinate of that point? It's probably pretty small on your paper, isn't it? -6. Right there. So that is telling us -1, -6 is our point. Okay. For our slope, we need the derivative at -1 because the derivative gives the slope of the tangent line, right? So we're finding f prime of -1. Mason, what are we going to get for f prime of -1? 4. We're just looking at our table because the table tells us the derivative right here when x equals -1, f prime is 4. Right? So 4 is our slope. And so for our answer, we just need to write that equation of a tangent line. So we're going to have y equals 4 times x plus 1 minus 6. If you want to do x minus -1, that's fine too. I just go ahead and switch it in my head. And then this is your answer. Well, this is your answer. It also asks you to graph it. So you got a few options on how to graph it. This is a point. This is our point of tangency, right? Our slope is 4. So from that point, we can just go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. Up 4 over 1. You could also go down 4 left 1, down 4 left 1, and draw in that tangent line right there. That's probably the easiest way. You don't even have to put it in y equals mx plus b to solve. Just take the point you know is on the graph and use your slope to graph it for that. If you wanted to put it in y equals mx plus b, you could. It's going to be 4x minus 2, but I wouldn't because you might mess it up. There's a few ways they can ask you something where you're going to have to, but they don't do it too often. So if you get a problem like this, it might initially look confusing because you got graphs and tables and all this stuff, but it's really like very little effort on it, right? As long as you know the things that you're trying to find. Here. All right, let's keep going. This is a difficult problem. We're supposed to find the equation of the line that is tangent to the graph of f of x equals x squared plus 4x and parallel to 2x plus y equals 8. Okay, I'm going to pull up a Desmos graph so we can picture what they're telling us to do here. Okay, so now this would be calculator inactive, but I think it's helpful for us to picture what we're talking about in order to think about what we got to do algebraically here while we're learning how to do these things. So where's my Desmos? I don't think I've got one open right now. So what we're looking at here is we got f of x equals x squared plus 4x. And I'm going to do this right here. I'm going to do this. So I would like to put an equation of a tangent line here. So if I do something like this, if I put a point A, f of A, and put a slider right there, it's going to give me a point on the graph. So if I wanted to write the equation of this tangent line, okay, it would need to be y equals the slope. Here's something pretty cool about Desmos. If I want to know the slope, I can do the derivative, right? The derivative gives me the slope. So if I type in f prime of a, Desmos does the derivative for you. Like it finds at 1.1, it tells you what that slope is going to be, right? And you can move it, and you can see the derivative changes whenever you move that point. So this is my slope. So I could do y equals f prime of a. There's my slope. And now I got to do x minus, what's my x coordinate of my point? Here, if my point is a, f of a. Let's label that. What's the x coordinate of that point? It's a. So in my equation, I'm going to put a right here. And then I got to do plus the y coordinate. What's the y coordinate of that point? F of a. And so you don't have to know how to do that in Desmos. I was just going to walk us through like that same process. But that puts, like, now I've got a tangent line that I can move around, right? So the question is saying we're supposed to find the equation of the line that is tangent to the graph of f of x equals x squared plus 4x and also parallel to 2x plus y equals 8. So let me graph 2x plus y equals 8. You don't have to solve it for y because Desmos can graph everything, but to do it algebraically, we don't have to solve it for y. So I could move this around a little bit. We're actually probably pretty close right here. Let me get the different color for. It wants the tangent line to be parallel to that green line that we have right there. So, like, definitely over here, that's definitely not parallel. So my answer's not over here anywhere because I have like a positive slope and negative slope. That's not going to work. So it's definitely over here somewhere. So like a -3. What's my slope there? -2. I think -3 is going to be it because I think the slope of this graph is -2, and I think the slope of this graph is -2. So I think -3 is going to be like the point where that happens. All right. So like visually, if I've got that tangent line that I can move, I just am kind of moving my point until I get the lines looking pretty much parallel, right? But if it's calculator inactive, how am I going to think about doing this, right? Much more difficult to think about. So how do we know, algebraically, how do we know that two lines are parallel? They have the same slope and different y-intercepts. Because they got the same y-intercept, they're the same problem. So have the same slope. So if I have this, where am I at? If I have this equation right here, if I've got 2x plus y equals 8, how do I find the slope of that line? Move the 2x over, so I'll get y equals negative 2x plus 8. And what is the slope of that graph? It is our negative 2. Okay, so it's pretty simple to find the slope of that graph. As y equals mx plus b, our Math 1 kids should be able to do that. Well, they're not there yet this semester, but give them till Christmas and they should be able to do this, right? Theoretically speaking. Anyway, so they should be able to do this. This is a pretty simple idea. So that is the slope of just the line that we know, that green line that we graphed. I need the slope of my tangent line to be equal to that, right? What do I have to find the slope of the tangent line? So we know slope of my tangent needs to equal the slope of this line over here, which is negative 2. And the slope of the tangent is f prime of x. And this question will get a lot easier once we know the shortcut. Some of you may already know the shortcut, and that's good to check your work, but we can't officially use it yet because I haven't introduced it. So if we want to find f prime of x, we'll have to use our limit definition of a derivative that we used yesterday. It's h, not an x. That's an h right there. H approaches 0 of f of x plus h minus f of x all over h. You don't have to write that every time, but I just like to so we remember what we're working with here. So f of x plus h, I'm going to do that over here to the side. We're going to have x plus h squared plus 4 times x plus h. And so that would be x squared plus 2xh plus h squared. And then we'll distribute that 4. So we'll get plus 4x plus 4h. So in our formula here, we will have that stuff, x squared plus 2xh plus h squared plus 4x plus 4h. That's just, that is just our x plus h part right there. So we still have to subtract f of x, which is just the function x squared plus 4x. All this over h. And this here, that's our f of x. I'm running out of room, so I'm going to distribute this negative right here. That's going to make this negative, and it'll also make my 4x negative. So my x squared cancels with my negative x squared, and my 4x cancels with my negative 4x. That leaves me with 2xh plus h squared plus 4h all over h. This is good because everything I'm left with has an h there with it. So I'm going to do the limit as h approaches 0. Let's go ahead and factor out the h. So we got 2x plus h plus 4 all over h. Our h's can cancel. I'm going to go ahead and plug in my 0 for that h. So I got 2x plus 0 plus 4. So I get 2x plus 4. Now, on this problem, I couldn't do the limit definition of derivative at a point because I don't know what point it is, right? I've got my derivative, but I don't have my point. In fact, I know f prime of x is going to equal -2. Like, I know the value for the derivative, but I don't know what point it is. The point is what we've got to find here. So what should I do now that I've got f prime of x? Yes, because I know f prime of x needs to equal the slope of this other line, which is -2. So that's going to be a simple equation to solve, right? I'm going to have 2x plus 4 equals -2. I'll just subtract 4 from both sides. 2x equals -6. I will divide by 2. So x will equal -3. That is the x coordinate of my point. I am almost there. I'm also very much out of room. Here, it's going to start getting messy at this point. That's my x coordinate of my point. I've already got the slope, because whenever we're doing an equation of the line that's tangent, I need a point, I need a slope, and I need the equation. So we have already found, we knew pretty early on the slope needed to be -2, right? We just found that -3 is our x coordinate. How do we find the y coordinate that goes with it? What, Jericho? Plug in -3 in to the equation up here. So I'm just going to do this here in the middle where I've got a little space. At f of -3 is going to be -3 squared plus 4 times -3. So that is going to be 9 minus 12. So I will get -3. So -3 is going to be my point of tangency. And now I need to write that equation, which is just going to be y equals -2 times x plus 3 minus 3. And that right there will be my answer. Okay, so there's a lot going on there. Good news is we got about 30 minutes for you guys to work on your homework, so hopefully you can get a pretty good ways on that, if not all the way done. Also, if you are like, you got test corrections or FRQ questions you'd rather do first before you do that, that'd be fine too. I'll help you with those. Let's see. 25, 27, 29, and 30 are all tangent line problems. So you have to find the point. Actually, they give you the whole point. You don't really have to find the point. You have to find the slope, which is going to be the derivative at that point, and then you have to write the equation of the tangent line. For those, you can use the definition that we learned on Tuesday, I guess. You can use that definition at a point for that one. For 34 and 36, those are like the last example that we just did. You're looking for the tangent line and the line that they're giving you need to be parallel. So it's like example 8 for those last two. So we got 6 problems. That sounds like nothing, but you know not to believe that anymore. 6 problems can take you an hour sometimes in this class, so hopefully not. Hopefully a little less than that. But go ahead and get started. I'll be around to help, and if you need help on any like test corrections or anything like that, I'll be glad to help with those too.